Okay, welcome back, everybody. I hope you had a good lunch break and got a chance to see the poster session. There were amazing posters there. We now have the first of our two keynote speakers, followed by a panel and the last keynote speaker. I want to thank Ellen Douglas for coming in at the last minute and rescuing us. We had Tony DeBrum from the Marshall Islands who was going to talk about sea level rise, but we wanted to talk about sea level rise as you saw the issues in the previous panel. And so Ellen has graciously agreed to talk about them. We've had the stage set with the previous panel, and on Monday this week, we also had Carrie Emanuel from MIT talk about hurricane risk and how to evaluate hurricane risk, which it turns out is not a trivial matter. One point that he made, and which is quite interesting, is that number one, sea level rise is not the same throughout the globe. It's going to change depending on where you are for various factors, not the least including, say, gravitational attraction. So we know roughly how fast it's rising here, but we don't know if it's going to take off. There's a range of climate models. And when you start to think about mitigation, which is probably what we're going to have to deal with because we've already dumped CO2 into the atmosphere and we're going to have to live with it and live with ocean level rise, then the question becomes, how do you mitigate it? And that mitigation is going to depend very strongly on where you are, what the coastline looks like, and what the bathymetry is. So Ellen, who's a professor of hydrology at UMass Boston, has studied this extensively and has worked on mitigation strategies for cities and is actually very directly involved with developing mitigation strategies for Boston. So we'll have a talk and have about 15 minutes for question and answer afterwards. So, Ellen, thank you.
Hi, everyone. Can you hear me? Is my mic on? Oh, great. Okay. So yeah, thanks for having me here. Happy to fill in the last minute. I love talking about sea level rise and how we can deal with it in Boston. So what I'm gonna do is give you a whirlwind tour of some of the projects I've been involved in dealing with that. But I wanted to give you a little bit of a precursor to begin with. You know, we're used to hearing recently about a lot of different records that are being broken, right? We have record temperatures every year, we have record temperatures in the months, and just recently, July 2016 was deemed the hottest month ever recorded, so we're breaking a lot of records. And I always like to mention that records are always going to be broken. Theoretically, they'll always be broken, but usually what happens is the time between records increases. But what we're seeing with climate change is that the records are being broken faster and faster and faster, and so it gives us an idea that something's going on. Also, I don't know if you noticed, but just a couple of weeks ago, we had a king tide, and so there was a whole bunch of pictures that were taken of places around Boston and the surrounding area where you see that there's water just at high tide in places that generally didn't see flooding before. So more evidence that things are happening that are unprecedented. And of course, we know this from the International Panel on Climate Change, when in their last report where they came out and said that warming is unequivocal. In other words, there's no doubt anymore. And it's extremely likely that humans are the cause. And so what do we do with that then? Well, one of the things that Boston did was the Green Ribbon Commission, which is a part of a little committee in Boston, decided they wanted to do a vulnerability analysis for the city of Boston, but before that, they wanted to pull together a scientific consensus on what climate change means for Boston. And so this Climate Ready Boston initiative was born just last year, summer of 2015, and the first thing we did was bring together 4 teams of scientists from around the city to look at what is the most recent science on climate change impacts for Boston with regard to temperature, storms, precipitation, and sea level rise. And I'm going to talk to you about sea level rise. So the ultimate outcome of this project was they took the consensus from the scientists, did a vulnerability assessment, and then next we'll look at plans for reducing the vulnerabilities that they identified. I'm going to talk about, so this was called the Boston Research Advisory Group, or BRAG. I'm going to talk about the results of the sea level rise team in the BRAG. This is a list of the people that were involved in that team. Myself and my colleague Paul Kirshen at UMass Boston led the BRAG teams. So I don't know how much, this is kind of last minute, so I don't know how much you've already seen about sea level rise, but I want to talk a little bit about the processes. There's a lot of different factors that go into sea level rise. Of course, as the water warms, it expands, so that's called thermal expansion. Also, you have melting of ice, of glaciers and ice sheets, adding volume to the water. Have vertical land movement, so sometimes in some places the land is subsiding, some places it's uplifting. Compaction, other things, all these add to sea level rise as we experience it at any location. Over the 20th century, thermal expansion was really the driving factor. But in the 21st century, as we move further into the 21st century, what really is striking is the potential for ice melt and the melting of the glaciers to really add and accelerate the sea level rise that we see. So in the ice sheets, there's a potential of tens of meters of sea level rise, were they to all, and now they're not going to all melt in the next few centuries, but there's a big potential, and that's one of the big uncertainties in being able to project sea level rise, especially out into the later part of the 21st century, just how much of that ice is going to melt. So the other thing that I know Carrie talked about earlier this week was that sea level rise is not experienced in the same way in every location. So here in Boston, we're not going to see just global mean sea level rise. GMSLR is just global mean. That's just the average sea level rise around the planet. We're going to experience a different rate of sea level rise because of this vertical land movement. Here in Boston, we're actually subsiding. And part of the vertical land movement is in response to glaciers that were like 12 to 20,000 years ago. The land is still adjusting to that. We also have changes in ocean dynamics, which I'll talk about in a minute. And we have something that's called ice sheet fingerprints, which I think you've had a little bit of exposure to, but that is one of the coolest things I learned as being a part of this brag. So I thought it was very interesting, and I wanted to share that with you. So the ocean dynamics is as, you know, I'm a hydrologist, so I deal with freshwater. So I didn't have any real formal training in ocean dynamics, and I found out that the surface of the ocean is actually very bumpy because of currents. It's not flat like you'd think. And so as those currents make their way around the globe, the elevations of the water surface are very different. And so, and as those currents change, it affects the elevation of the water surface. So as warming occurs, sometimes we're expecting that some of the currents may slow down, which may cause a relaxing of the water surface at the current and shift the water level at the shoreline. There's also changes due to more or less saltiness in the ocean and warmth. And then we have these big what they call teleconnections, with these big climate events. One in particular in the Atlantic is called the North Atlantic Oscillation, which affects how currents, where currents go, and also affects the sea levels as well. So these ocean dynamics could impact sea level rise along the New England coast as much as 10 centimeters by 2100. So there's all these factors besides just the thermal expansion that add to the sea level rise we may see. This idea of ice fingerprints is pretty amazing. So as ice sheets melt, they add water. That's obvious. But one thing that I didn't realize, I never quite understood until I was a part of this brag, is that the ice sheets are so massive that they have a gravitational pull, and they actually pull the water up to them. And as they melt, then that mass reduces, and so their gravitational pull reduces. So when you're close to an ice sheet that's melting, the water level, even though water is being added to the ocean at that point, the water levels will actually depressing, going down. That means it's distributing further out into the ocean. So when you're far away from an ice sheet, the water level's actually going up because of that ice sheet melting. And so they can model, they've gotten better at modeling and predicting these kinds of impacts. So, I don't know, so this line here is how the ocean would look if it was just a flat surface around the sphere. But this line here shows that impact where the massive ice sheet is pulling the water up next to it. And then as the ice sheet melts, this water level actually drops here and goes up farther out. So we're going to be, because we're very far from the Antarctic ice sheets, we're actually going to be seeing more than global mean sea level rise because of this relaxing of the gravitational pull from the ice sheets, which I just think that's really fascinating. I would have never thought that. So because we're close to Greenland, as Greenland melts, we're actually going to see a reduction in sea level rise because we're close to Greenland. But Greenland is pretty small relative to the Antarctic. So as the Antarctic melts, or if it collapses, we're actually going to see as much as 20% or more increase over global mean sea level rise because of that impact of that mass redistribution of water. And so all those things were taken, the Bragg looked into all those different factors, and actually Rob DeCanto, who works at UMass Amherst, has a method for incorporating all that into a model that can then project levels of sea level rise, specifically for Boston here. So out of the Bragg came some specific predictions of sea level rise under the different emission scenarios. You probably learned something about emission scenarios. If we have low carbon emissions because we go to renewable energy sources, or if we continue on with the high burning of fossil fuels, we have high emission scenarios. So here is the high emission scenario, sea level rise. So it could be as high, the mean is like around 4 to 5 feet of sea level rise, could be as high as 7 feet of sea level rise by the end of the century. Whereas if we follow the lower emission scenario, so if we reduce our carbon emissions in the atmosphere, we could then have sea level rise that's more in the realm of 3 to 4 feet, 2 to 4 feet. So what we do now, the takeaway from many of the things that came out of the Bragg was, what we do now makes a big difference later in the semester. You can tell. Later in the semester and later in the century, right?
Quite a long semester.
Yeah, that's a very long semester, right? Yeah, you probably won't see the impact by the end of the semester.
Final exam.
The final, right. There will be a test at the end of this century. How did we do? That's good. So that was one initiative that Boston generated to try to assess what climate change means for Boston specifically, and they're just finally releasing, I think it should come out in the next month or so, the results of the vulnerability assessment that used the scientific consensus from the Bragg for the 4 impacts, and then look at places in the city that's vulnerable. Another project that I was involved in was actually funded by the Federal Highway Administration and Mass DOT. I'm an engineer, so I like to deal with, the stuff that's on the ground. So we were hired by Mass DOT and the Federal Highway Administration as part of the climate change pilot project to look at the impacts of sea level rise and coastal storms on the central artery, what we affectionately know as the Big Dig around here. So I'm going to tell you just a little bit about that. Here's our project team, and included several people from UMass Boston. Our modeler was Kurt Bosma from Woods Hole Group down in East Falmouth, and Mass DOT personnel. So we all worked together on this. And the main objective was to see what was vulnerable in the central artery project. And we're not just talking about the tunnel, but all the highway infrastructure and the tunnels that were a part of it. And then how could we, what could we do to reduce those vulnerabilities? So this is just an image of the central artery. I'm sure that you're all pretty, well, maybe you're not. You're not maybe from around here. So this is the central artery. Here's a picture of what it looks like now with the Rose Kennedy Greenway. Used to be, it was an elevated highway. Now it's a tunnel under the city. And so you can imagine that an agency like Mass DOT worries about things like tunnel entrances. What happens if water goes in the tunnel entrance? Or they have these big vent buildings. So when you got this tunnel, you need to ventilate it. So they have these big vent buildings. And they have vents right at ground surface. So you have to worry about what sea level rise or coastal flooding could look like in these areas. And I've done a lot of work. I've been working on this for over 10 years along with my other colleagues. And what we had previously done was just done what's called a bathtub map. So you just take a flat surface and you cut it through the terrain and you say anything below it's going to be flooded and anything above it is not. Well, that's fine when that's basically all you have the money or time to do. But really what you need to do is develop a model that can simulate waves and wind and ocean currents so that you know, because this map shows a flat surface at 12 feet where flooding would be in Boston. But this actually shows how a hydrodynamic model would simulate the same kind of an event. And so you can see the red means higher than 12 feet. So this is actually a simulation of a nor'easter. One of the reasons that nor'easters impacts us in Boston is because Boston Harbor is opens right up to the northeast. So people along the south coast here in Quincy and those areas are going to get higher impacts, and because of waves and because the water is pushed because of storm surge, than they are in the northern coast. So that's why we decided that because we had funding from the Federal Highway Administration and from Mass DOT, we built this big fancy schmancy model that actually includes much of the Atlantic, so we could bring in nor'easter storms and hurricanes to assess what flooding would look like from those events. And we also, because Mass DOT was interested in understanding the vulnerability of individual structures, so the vent buildings, the tunnel entrances, things like that, we had a very fine resolution grid, so all of these little dots, the model had a prediction for all those dots. So this ended up being a very large numerical model that was built. But it really was the next step that we needed to take beyond the bathtub maps. We incorporated sea level rise. We picked points off of the highest emissions scenario to look at what coastal flooding would look like now in 2030 and 2070 and ultimately 2100. And the outcome of this, this was like a 2-year project, and the outcome of this model was the probability of flooding at different locations throughout Massachusetts, throughout Boston. So it was funded by Mass DOT. They were most interested in the Mass DOT structures, but it also gave us a map where other communities all along the coastline could look at the results of this model and say, what does that mean for flooding for us as well? So this is an image of, as you can see, the Boston area, the green here. So this right now is the probability of flooding. So the greenish color is around 1% chance. So if any of you have ever heard the term the 100-year flood or the 1% chance flood, that's the one that FEMA worries about a lot. So we were able to actually predict what the probabilities of flooding were. And this is the green way in East Boston. Here we have South Boston. Here we have down where I am on Columbia Point, up here in Charlestown. So this is current conditions. So there is some probability of flooding in parts of Boston under current conditions, but the probabilities are low, less than 1% or less. But when we get to 2030, you see the colors change. Not only do the colors change, but the extent changes. So now the probability is more in the area of 2 to 5%. So now we're starting to see, rather than once every 100 years on average, we're seeing once every 50 years or more probability of flooding, and also seeing much greater extent of flooding in these areas as well. And then we get to 2070. And then we start seeing a lot of flooding. And in particular, we see a lot of flooding in here, in Cambridge and Back Bay, so what we're doing here is we're modeling sea level rise plus the addition of storms coming in on top of that, so storm surge. So by 2050 to 2060, somewhere around in there, if you get an event, a storm surge on top of a high tide, it can actually get around the Charles River Dam and the Amelia Earhart Dam, and then you begin to have flooding in these areas that weren't used to being flooded, because that's why the dams were put there. So we have flooding in Cambridge in those areas, a lot of flooding up in Charleston and Somersville, and of course, South Boston, South End, and all these areas. So this gave Mass DOT a chance to figure out what is the risk, what's the probability of getting flooding. And we could also take a particular probability, a 1% flood probability, and see what the depths would be. So here we're looking at the same sort of a scale. The Greenway in East Boston under current conditions has a potential, if it's a 1% event, if that occurs, the depths are going to be around a half a foot to a foot. So not anything probably terribly disruptive, but if you get into 2030, then you get an extension, then the flooding depths get more extensive and they get deeper. And again, as you can imagine, by 2070, not only do you have a higher chance of flooding in more areas, but you also have more depths. So this gave Mass DOT and anybody else basically in Boston that's interested in the impacts of coastal flooding, which is the combination of sea level rise and coastal storms, some information to how to plan, how to think about what sea level rise could mean. And of course, we can zoom in, Mass DOT and others can look at individual infrastructures. I showed this map to a bunch of CEOs that had property in South Boston, and there was literally a verbal gasp in the air because the blues are around 30 to 50% probability by 2070 of flooding. So that's a really high probability of flooding occurring in these areas. So then you can start looking at what are we going to do about it. So other things that come out of this model are the timing. So the water comes in, we know what the depth is, how long does it last? So how deep it gets, how long the flooding lasts, then you can start figuring out what you're going to do about it. So you could do something as simple as putting up flood-proof doors. We found out in the Big Dig, there are a lot of doors. There are an enormous amount of doors. So as they replace doors over time, they replace them with flood-proof doors. So that's a fairly easy fix. There's also in areas that's going to be flooded, but it's going to be either less than 2 feet or it's going to occur just over a very short time. You can put up these things called temporary flood barriers. Aquafence is a builder of these temporary flood barriers, and Massport actually has bought a system of these temporary flood barriers, and this shows a picture of them doing an emergency, to see how long it took. It took them like, I think, 45 minutes to put up the temporary barriers around this particular building. So they went out and did a drill. So there are ways that you can protect yourself that aren't terribly expensive and can be sort of put away in the warehouse. And then the good thing is we have 3 to 5 day lead times now for big storms that are coming. And so you have time to prepare. So this gave Mass DOT a chance to really think about or to know what sea level rise and coastal flooding would mean for their particular infrastructure, and then to be able to plan. So the good news for them and for Boston is that over the short term, currently there is exposure, there is risk of flooding, and we kind of all knew that, right? Now we just know what the probability is. So it's fairly low probability right now, so we have time to figure out how we're going to deal with this. But by the time you get to 2030, you have to start worrying about more substantial flooding and incorporating this flood proofing and accommodation into the maintenance of these particular buildings. The bad news is there were some, even under current conditions, there are some tunnel openings that are vulnerable. So you have to think about what we would do if a storm did come in, and those vulnerable tunnel openings do increase over time. So Mass DOT is doing a lot of ground truthing right now, making sure that the stuff that the model said is actually true. And then they're also developing a plan over the long term with how they're going to incorporate this information. Just one more quick thing about other things that we've been doing related to sea level rise in the Boston area. My colleague Paul Kirshen and I have been working for about the last 8 years in East Boston. We had a research project that was funded by NOAA, the National Oceanographic and Atmospheric Administration, who was interested in knowing what sea level rise and coastal flooding means for environmental justice communities. And so we picked East Boston as a focus area. And the first thing we did was we had 2 research projects. So this is research in action. We had 2 sequential research projects where we went in and met with East Boston residents, found out what they knew about climate change. We gave them some ideas of what we knew about climate change, and then surveyed residents to find out, and told them about what are the options. How can you protect yourself? How can the city protect itself from these flooding events? And then got feedback from the individual residents as to what they felt would work and wouldn't work. And out of that then came a series of workshops where we brought together people from Boston agencies, Massport, Mass DOT, National Grid, the City of Boston, all kinds of agencies that were going to be doing individual adaptation strategies in East Boston, brought them together with the residents of East Boston, had some workshops where people shared their values and their priorities. The whole purpose was, the hypothesis here was that if you develop a plan, rather than having all the individual agencies develop their own plans for their own infrastructure, if we got together and came up with a plan that shared the plan across agencies and across stakeholders, we could not only meet the requirements of the individual agencies, but also have a lot of co-benefits for the residents and other people involved in the area. So we brought together, and this was mostly led by Paul Kirshen, the residents with the governmental and infrastructure agencies, shared values, and then and plans, and then engineers came up with a conceptual flood protection plan for East Boston. So people just got together, rolled out these maps, and said, okay, what's important? People listened to different stakeholders giving presentations and sat down and hashed out what was important, and ultimately came up with a map of important features within East Boston that needed to be protected, that were valued by both the residents and the government agencies and infrastructure agencies that were involved. And ultimately out of this came a conceptual plan for, that included a flood wall, it included some landscape berms and some beach nourishment and things like that. And the great thing about this is, since the NOAA, funded research that we did lasted for 6 years, and then Paul and the NOAA, NOAH, which is the Neighborhood of Affordable Housing Community Advocacy Group in East Boston, went and got a Kresge grant. Yeah, so we were funded by NOAA, and we were working with NOAA. It was hard, NOAA, NOAH. So got a Kresge grant to actually develop a real adaptation plan for the city of Boston. And then very recently, the coastal zone management, it's hard, that's kind of washed out, but the coastal zone management has given the city of Boston money to actually start designing protection for East Boston, and that includes, so one of the things that came out of this model, so you saw the flood maps in the model, the flood maps from the model that showed flooding and the probabilities and the depths in different places. The other thing that the model shows you is flood pathways. So there are places along the coast that are an entryway, that if you block that entryway, you can actually save a lot of the flooding behind it. So what the Coastal Zone Management, Massachusetts Coastal Zone Management, has actually given money to a grant to the city of Boston to develop designs for closing those gaps. So one of the gaps was the flood pathway that leads to all that flooding that happens in the East Boston Greenway. The other is a flood pathway that leads to flooding that comes in up by the Schrafft's building, up in Sullivan Square, and that leads ultimately to water that gets behind the Charles River Dam. So you close these two flood pathways and you save a lot of flooding, so you don't have to do all of that individual home flood proofing. So I really like this East Boston project because it started by talking with the residents and now has ended, is currently in sort of design stage. So it was really a great example of how you can work with a whole bunch of people and come out with something that's actually going to happen, be on the ground. So I'm going to end there. My colleague Paul Kirshen started this work in East Boston with a study called CLIMB. It was Climate's long-term impacts on Metro Boston. And one of the takeaway message from that was that the most expensive option when dealing with climate change is to do nothing. So that's what I wanted to leave you with.
Thank you very much. So we have time for questions allocated. They're bringing the mic up to the front. So we ask that you line up and identify yourself and ask your question. I don't know if it's out of key to talk about another town in the area, but so every winter there's a nor'easter, and we see these news things of Situate.
Yes.
And Situate, I'm just kind of boggles my mind that it's there, and I just don't know what will become of Situate in the future in 2070. So.
Yeah, well, Situate's been the focus of a lot of, Coastal Zone Management has a lot of, they've done a lot of monitoring there. They're doing a lot of site-specific evaluations of how to protect Situate because it's just the geometry of the embayment there that they get blasted.
Yeah.
It's the way, they're just unlucky, I guess.
Okay, so we'll take our first question.
Hi, I'm Alyssa Goodman from Harvard and this year from Radcliffe. And my question is, in Chicago, I know that in the middle of the 19th century, they raised Chicago up, all the buildings and all the land, about 6 feet because of Lake Michigan smells. But anyway, I'm curious whether actually raising the city is just so expensive or so impossible that that's not even part of these plans, or is part of that thinking in there?
Well, you know, we haven't gotten to, so what most agencies in Boston and entities in Boston have done at this point is either they're in the process of or have completed vulnerability assessments to know exactly what is vulnerable in the city, and in the city of Cambridge and a lot of coastal communities along the coast are doing these vulnerability assessments, looking at different levels of sea level rise and saying, okay, what buildings are going to get flooded and things like that. Now, once those vulnerability assessments are done and we're getting to the end of that phase, that's when the hard part comes to try to figure out what to do. I've heard people talking about raising the city. There's another thing that people have talked about for the last probably 20 or 30 years about putting a barrier along the harbor islands. So those are the kinds of things now that we're going to have to start looking at the feasibility of. You know, there's all those ideas, but is it really feasible to do it? So I don't have the answer yet, but maybe in 10 years.
My name is Ned Bacon. That last comment goes really directly to my question. I'm aware there have been a lot of studies. There's been a lot of talking about the problem here in Boston, which is the really easy part.
Right. Talking is always easy, right?
Yeah. And at the same time, I see this enormous amount of building that's going on, particularly down in the Seaport District. And I'm wondering if the people who are doing that, or you see General Electric coming in and getting financial concessions from the city as opposed to contributing to a potential solution to this problem. I'm wondering if those, I don't know if you're in touch with the developers in that community, but are they living in a parallel universe?
Well, I can't, you know, I have given these talks so many times that I can't believe they are living in a parallel universe. You know, so one of the reasons that the Climate Ready Boston initiative came out was to really focus on Boston and figure out what's vulnerable and, you know, how much and what needs to be done. And this Mass DOT study that I showed you was done, you know, funded by Mass DOT and the Federal Highway Administration, but it's also available to pretty much anybody who wants to use that information to figure out what their vulnerability is. So the information's out there. The city is not, to my knowledge, now I'm a hydrologist, I'm not a policy person, but to my knowledge, the city is requiring that people who build, they're requiring that they incorporate, that they account for climate change in some way, but they're not specifying how they do it. But, and I know there's been a lot of, you know, murmuring about, you know, the fact that General Electric is building this big building in the middle of the seaport where you see there's going to be a 50% chance of flooding. And so I've heard talk about, you know, making the first floor 12 feet instead of 8 feet so that, you know, they can actually lose the bottom 4 feet and still have an 8-foot structure, you know, things like that. So I don't believe that people are unaware, but it's certainly not stopping them. That's all I can say. It is. There are a lot of people that shake their heads, yes.
Hi, how you doing?
Yes.
Matt Mulvey. I'm a division commander in the 1st Northern District for the Coast Guard Auxiliary, but I wear another hat with the Department of Defense in the Air Force, and I'm dealing with a lot of potential construction on the Atlantic coast. And looking at the FEMA maps, should I add another foot or two to those when I'm looking at base flood elevations?
To the FEMA maps. Well, yeah, so FEMA is, how much are you going to pay me for this advice?
Well, the projects we do, we expect them to last 30 or 40 years, and I don't want to go into some building that's got 4 feet of water in it based off the maps that we have now.
Yeah, so the FEMA maps are simply look backwards in time. They don't incorporate climate change at all. So FEMA maps are developed using the historical data, and this is by law. I mean, FEMA has no choice. This is how Congress designated that they would develop these flood insurance rate maps. They look in the history, they figure out what's the probability of flooding given our historical record. 100 year, 500 year, so that's the 1% chance and the 0.2% chance of flooding. What you add to that, that's one of the reasons we did this big model for Boston, because we added sea level rise into Boston and allowed the model to simulate storm surge and wave actions and things like that, because there are a lot of other things besides sea level that's going to impact the coastline. And so what you add to the FEMA maps, if you're going to do that, it all depends on how vulnerable, how much risk you can take. So if you have a system, if you have a building that, if it gets flooded, oh well, it's messy, but you just clean it out and you put stuff back, then you could probably handle a 5 or a 10% chance flooding. But if you have something like the Big Dig, where people drive through it and you don't want it to fill up, then that has a very low risk. I mean, you can only handle a very low risk of flooding. So those sea level rise projections, remember that I showed you, those things that tailed up depending on what the emission scenarios looks like, you have to make a decision as to how much risk you are willing to take, and then based on that, the lower the risk you can take, the higher you have to raise your elevation. So I can't give a one-line answer to that. And I wouldn't anyway, because I'm not getting paid. No, I'm just kidding. Go ahead. I don't know if that answered the question, sorry.
So I'm Pete Gerges, I'm on the faculty here. This is all in the context of flooding, but I'm really thrilled to be able to ask a hydrologist this question. So what are the potential impacts on freshwater? In other words, as we start to see sea level rise, are we going to see impacts on freshwater, on our water table, and do you have a sense of how extensive that might be? Thank you.
Yeah, that's a really good question. So I have been, it's interesting, I'm a hydrologist and I got involved in sea level rise for the last 10 years, and I'm finally getting to the point where I can start looking at freshwater impacts again. So, you know, in Boston and in many coastal cities, we have that dual impact. We have the ocean coming in from one side, and we have rivers with floodwaters coming in from the other side, and we also have storm drains, right? Where do the storm drains end? In the ocean. Usually, you know, and when they were built, it was above high tide. Well, when high tide rises to the point where it plugs up the end, then that storm water that comes in, usually when we have a storm come in and we get a storm surge, and so it goes above the elevation of the outlet of the storm drain, and so water can't flow out there anymore. We also have a lot of precipitation falling and a lot of storm water that's trying to get out of that drain and can't because it's being blocked by the storm, by the storm tide. And so what happens is the water just backs up. So the combination of freshwater flooding and ocean flooding is going to be that upstream, there's going to be a lot more flooding upstream and upriver because the water just can't get out the way that it would normally. Now in the Charles, we have the Charles River Dam that was actually developed, designed with six massive pumps that were designed to pump the largest flood that was ever recorded on the Charles. So the Charles River Dam is actually going to be okay for a while, up until 2060, 2065. It's going to be able to maintain that level. But the storm drains and all the smaller rivers are likely going to see more flooding upstream because of that.
Lisa Tripp, what about the airport? I notice it's close to what you put on your map, but it doesn't involve it. Is it somehow immune from all these floods?
No, actually it's not, and that's a very good question. So the maps that I showed you were made for Mass DOT, so we basically masked out anything that was outside of Mass DOT infrastructure, but Massport asked that question a long time ago, what about the airport? So actually they've used a lot of the output from the model that was built for Mass DOT, and one of the things that Mass DOT did right from the beginning is say, we're going to make this information available to other agencies and other communities that want to use it for their own, because it's the best available information right now that there is in the Boston area. And so Massport has actually done their own vulnerability analysis already, and that's why they bought the temporary flood barriers, because they now have a really good idea of, interestingly, it's not until about 2070 that the actual airport itself is impacted. It's fairly high up. It doesn't look it when you're landing, but it's actually fairly high up above the high tide. But they do have vulnerability, and they actually have a resiliency officer now who has implemented a lot of strategies for dealing with that. Because the airport is an important recovery and evacuation component as well as normal transportation.
Hi, my name is Gwyl York, and I'm asking this question as the chair of the Museum of Science here in Boston. Really was happy when I've seen these maps that the museum's okay until 2060, so that was phew. I'll be long gone. But I wanted to ask, because I've now been starting to see a lot of maps and thinking about where the water's going to go, and the Green Ribbon Commission is convening, and we convened all the cultural institutions in Boston at the Museum of Science earlier this week to talk about this, because we've got collections, and not everything. We have historic buildings, we have all kinds of different things. But I asked in that there, and I'm going to ask here, who's convening everyone? Because it was just Boston, and I live in Cambridge, and there's Arlington, and there's Somerville, and there are all these different communities. So where's the conversation about having us really be coordinated? It looks like we're, as you said, coming up with the end of figuring out where the water will go if it's just left, if we do nothing. But who's coordinating all this activity and great research and
That's a
turning into
very
action?
good question. I've actually been thinking about this question a lot because as a hydrologist, I think about stormwater a lot with extreme precipitation, and every town is responsible for their own stormwater management. I mean, wouldn't it make sense if all the towns got together and came up with a plan that worked so that everybody could sort of take advantage of the information others had? That all makes logical sense. And actually, when it comes to the adaptation for coastal flooding, that's beginning to happen. So because of the flooding is so extensive and it gets worse over time, people within the city of Boston and surrounding communities are starting to work together. There's this, I forget what it's called, but there's a group of mayors in Boston and surrounding communities. It's called the Mayor's Summit or something like that. I should know the answer to the name of that. But anyway, they've gotten together to commit to working together to come up with a plan. The same thing has to happen in other areas of climate change impact with precipitation and flooding and things like that. I don't think it's happening yet because one of the drivers here in New England is we are a home rule place. So every town has jurisdiction over their own things, and people don't always like to work with other people because, number one, it's kind of overwhelming to think about dealing with somebody else's problem when I can barely deal with my own. But I think we're going to have no choice but to move towards that. But I don't think it's happening. It's beginning to happen, but it's not happening as much as it should probably yet. But the more we talk about this stuff, it will.
Okay, thank Ellen again. Thank you so much.